Here we go. ENSO turns neutral. I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, April 27th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. And with that, I'd like to thank the folks that donated last week. Tim Caston, Evolution Moto, Clay Goose, these are longtime contributors, and E. Slade as well. And then some new contributors, Leonaro Roberts and BC Hall. Thank you all so much for your contributions. I do really appreciate it. With that, let's get to work. We'll start by looking at significant wave heights around the entire planet. Starting in the North Pacific, nothing going on, no big surprise. Southern Pacific, looking much more active. In fact, the most active location anywhere on the planet. 1, 2, 3, 4 different gales in various stages of their life. The main one here was seas at about 32.8 feet right there, developing south of New Zealand. Another one with 25-foot seas, another 25-footer, another 26 to 27 feet off of South America, and then even one up here in the upper reaches of the South Central Pacific with 22-foot seas aimed off to the northeast. So a pretty active pattern going on. Then we go over to the North Atlantic, pretty quiet there, maybe 18-foot seas just south of Greenland. Another gale over South Africa with maybe 31 or 32-foot seas. And then in the Indian Ocean, 18 to 20-foot seas there and 20-foot seas south of Australia. But the main focus really is the South Pacific. But first up, let's take a look at current conditions. We're going to start off of Oregon there, actually the Oregon-Washington border, Columbia River. Grays Harbor buoy number 036. We're looking at all the energy that's hitting this buoy, all the way up from 33.3 second period. That'd be very strong swell energy, 1/10 of a foot, all the way down to 5 second period. That'd just be like basically unrideable wind chop. You see actually 3 distinct peaks. One here at about 8 seconds, another one at 15, somewhere between 15 and 18 seconds. You even see another little bit of energy out here at 22 seconds. Primary swell, 5.8 feet at 8.1 seconds from 305 degrees, making surf at about 4.5 feet. Then that secondary swell, 1.3 feet at 16.1 seconds from, says 244 degrees, but it's more like 210 something. And that would theoretically make surf at about 2 feet. Heading south, we go to Northern California, the Point Reyes buoy, number 029, just north of the Golden Gate. Same sort of profile, whole bunch of wind swell here in the anywhere from 6 second up to about 10 second range. And then a bit more southern hemi swell in the 18 to 17 second period range. And then some other little energy down all the way out to 28 seconds, something like that. It's probably not real. At 28, you would need a storm with like 70 knot winds or better to make that, and there hasn't been anything like that. Anyway, let's see how we do here. Primary swell, 6.9 feet at 8.1 seconds from 315 degrees. That'd make surf at maybe 5.6 feet. And then the secondary swell, the main swell, 2 feet at 17.3 seconds from 205 degrees. That would make surf at about 3.5 feet. And that's pretty much what it is. A bunch of wind swell with southern hemi swell tucked in underneath at protected breaks. You can actually find the southern hemi swell, but there is a whole bunch of wind lump in the water. So then we go down to Southern California, protected from all the wind swell by the Channel Islands, and we see there's a little bit of the wind swell there at 7 or 8 seconds, but you see much more swell proportionally in the first southern hemiswell, which really is comprised of two southern hemiswells sitting anywhere from 14 seconds up to about 18 seconds. And then another southern hemiswell starting to show with half a foot at 22 seconds showing up. Let's see how the algorithm does here. Primary swell 2.4 feet at 15.8 seconds from 192 degrees. That would make surf at 3.8 feet. At top swell magnifying spots, you could maybe get 1.5 or maybe 1 3/4 more on top of that. So, and then the secondary swell, 1.1 feet at 19.7 seconds from 182 degrees, throwing another 2.2 feet, not on top, but just in the mix, so you get a more consistent southern hemi experience, something we would all appreciate. Then we go over to the north shore of Oahu, the Waimea Bay buoy number 106. And yes, believe it or not, there is a little bit of northern hemi swell still arriving in the Hawaiian Islands. You see the energy profile here, peak energy 13.3 seconds, and then some local wind swell in the mix. Primary swell 3 feet, 13.1 seconds from 318 degrees, making surf at 4 feet. You know, Hawaii magnifies that. There were head high sets when I looked this morning. And then that wind swell, 1.9 feet at 9.1 seconds from 107 degrees, and really inconsequential. So what has been going on in our oceans over the past week? We look at the Hindcast. This goes back to last week's video, 18Z on Sunday, the 20th of April. We'll just put this into motion because there was a gale here that developed off of Japan, producing 26.3 foot seas. Did it get higher than that? Let's take a look. 28 foot, is that 20? Yep, sure enough, 28 foot seas. Well, it's really 27 with maybe 1 pixel buried in there. This is the highest seas over this entire domain here. Winds were up to 40.7 knots at the same location. So that produced a little bit of a swell that eventually radiated into Hawaii. I think it was on Saturday. That is fading as we speak now. Oops, and that gets us right there to today's time, 12Z on Sunday. Then we go to the southern hemi, the South Pacific. Remnants of a gale fading currently. Oh, this was as of Friday. This is the Friday, the 18th of April. A gale with 26-foot seas was fading. A new gale started developing under New Zealand with 33-foot seas. Some of this energy is already arriving in California. This is really the main one, the next one in flight. This was, let's see, 32-foot seas. This was on Saturday, faded out. Then it rebuilt with 28 to 30-foot seas over a broad area, pushing out of the Southern California swell window on Monday. That was a week ago. Then after that, the Pacific took a little bit of a break. Yes, there was a gale here that developed on Wednesday with 34-foot seas building to 35 feet. And then up to, well, this was 38-foot seas here. Notice the anomaly popped up again on Thursday. I actually went and looked at, the satellite-based data on, like, icebergs and things, and there was nothing obvious that I saw down there, but that doesn't mean that it isn't so, but I suspect it's more of an anomaly. Anyway, this gale pushed off this one east of the Southern California swell window, all aimed southeast. No swell is expected from that. Then on Friday, the 25th of April, another gale developed with 45-foot seas over here, but then this guy came in with 43-foot seas on Friday night. That was just 2 days ago. That is the next swell in this series bound for California. Now, most of this is not going to get to Hawaii because the track on all these storms has been pretty much due flat west-east. Even California, the surf would be much bigger if these storms were lifting off to the northeast, but they're not. So it's all only sideband energy. I mean, the main recipient of all the swell energy would be Chile and Peru and up into Ecuador, and maybe we'll give Central America a nod on that too. Anyway, that was the end of that past week period. Then we go over to the North Atlantic. We'll just put this in motion. See, there was a little gale here that developed off of Newfoundland with 23-foot seas Oh, it says 25 foot in 1 pixel right there. Targeting Europe. That swell has already hit. You can see the leading edge of it hitting on Friday, the 25th of April. And then that faded out. And we'll just take this and run it on out to current time. Nothing else behind that. Then we go to the South Atlantic, just reviewing what has been going on the past week. Little gale, 22-foot seas southwest of South Africa on Wednesday, the 23rd of April. Produced some swell, kind of glancing blow up into South Africa, but then really moved off to the Indian Ocean. It's really interesting. You see everything loading up here in the Pacific, and nothing seems to make the jump into the South Atlantic. Sunday, we have a little gale falling hard south with like 35-foot seas. Probably not a whole lot going to be aimed off to the north. And then the Indian Ocean, we take a look at that. 28-foot seas were on Sunday a week ago, building to 30, pushing up towards Australia. Swell from that system has already come and gone. Another system did develop, if I remember correctly. Oh, no, that's a forecast. I didn't remember correctly. So that things were pretty weak after that, and that was it. Just 20-foot seas. But, so I sort of let the cat out of the bag. There is something much better coming. All right, so let's do a deep dive into the South Pacific. We're going to start by looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales when those gales form, help direct their track. We're looking for a trough, a push in the jet to the north. You see it right there. You sort of get the general sense there's something here. What that helps do is create a clockwise flow aloft in the upper atmosphere. And if it's strong enough, it manifests itself down at the ocean surface too. And a clockwise flow in the southern hemi is the hallmark of low pressure. Low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface. They generate seas. As the seas radiate away from the fetch area, the lesser period elements fade off and decay away, exposing the longer period swell energy. And that swell, of course, when it hits your beach, turns into surf. So we have potential here under New Zealand, a trough there, and something over in the far southeast Pacific, probably just eyeballing it, already out of the Southern California swell window, but good for relative to Chile and Peru. Put this into motion. The main trough, now this is a little concerning because you notice most of the winds are aimed southeast. You really want the winds over here in the western quadrant of the storm pushing north. That's sort of been the problem, though, with everything so far. So theoretically, we've either just in the past week or two, there's 7 swells that we're tracking, but all of them are in this, it sounds kind of, 7 swells en route to California, which is true, but most of them are all pretty small swells. Regardless, take whatever surf you can get when you can get it. Anyway, we're into Monday. The main trough, again, looks like it's more focused south than northeast. Second trough pushes out well out of the California swell window. Another sort of a troughy type thing here. Just even when you get winds in the southern hemi, they do seem to help at supporting gale formation. There we go, winds up to 150 knots. You see they start lifting north, so I guess that qualifies as a trough in this area. That would be on Thursday, the 1st of May, pushing to the far edge of the Southern California swell window on Friday, the 2nd of May. Then another trough starts digging out southeast of New Zealand here on Saturday. Notice the winds, pretty solid here, 150, almost 160 knots. That looks like a theoretically good trough, but notice it also gets pinched off as we get into Sunday, and right there's the end of the window, so nothing there, but then another trough right behind that. I mean, we are in a incredibly prolific pattern right now, though all of it really focused on Chile and Peru and Southern California and Northern California. Getting sideband energy in Hawaii, for the most part, is completely out of the loop, just nothing radiating up towards that location. So what effect does that have at the jet stream down at surface level winds? So here we are, surface level pressure, surface level winds. We know we have kind of a trough over here. We got 30 knot west-southwest winds. And then we have another trough over here south of New Zealand, a little tiny area of 50 knot winds, mostly 45 knot winds, all aimed for the most part off to the east. Let's put this into motion. There's our main system. Look at that. That's actually almost 55 knot winds, all aimed almost due north. I'll call it northeast on Sunday evening. That would be today. And then continuing on Monday, still with 50 knot winds as it pushes its way. Oh, and rebuilding almost to 55 knot on Monday night in the southwest Pacific, moving into the central Pacific, still with 50 knot winds on Tuesday, the 29th of April. Another little gale builds behind that. See if it gets any energy. No, I mean, you really need 45 knot winds. Also notice these arrows are pointing southeast. That's not particularly favorable. Then we know there's another trough forecast over here later in the forecast period. Yeah, you see 35 knot winds. Again, all aimed south. Sort of a cutoff low, if you will, with maybe 40 knot winds there on Sunday. And we'll put this into motion. Then here we go, 50 knot winds. This one, on this morning's run of the model, it actually formed a little bit earlier and lifted well to the north, east of New Zealand, which would be great for Hawaii. We'll see how this plays out. Again, anything 180 hours out, I wouldn't believe any of it, but it all still looks very promising. All right, so here's the wave model. What effect do those winds have on the ocean surface? Here we go for the next week. We shall see. Again, one gale here off of Patagonia, another one creating, 24-foot seas. Again, not really doing a whole lot. 23-foot seas, that's good for Tahiti, but probably not for anyone else. Just, you don't get enough period, the swell decays before it gets up into the northern hemi. Something developing under New Zealand. We'll put this into motion. There we go. 36-foot seas on Sunday evening, building to 37 feet. And back to 36 feet. Just look at the track on that. It is almost due east, literally no motion to the north. And then it continues off, if anything, even slightly falling southeast. Now the question is this anomaly real or is this just some garbage in the model? Because if it is garbage, my guess is sea heights are actually going to be higher than what the model says. These are kind of cutting the legs out of it here. So that's something to keep an eye on. Anyway, one system there, that was like a Sunday, Monday, Tuesday sort of thing. Then a bit of a break, and then we're waiting to see what happens. We're already a week out, and there's the last frame of the model. One system under New Zealand, another one over the southeast Pacific. So a bit of a pause in the action, it seems like, and then maybe things regenerating again. Going to the North Pacific. Now, we didn't go look at all the wind model and all that stuff because it's just too much data and the videos are long enough as it is. But as we get into Monday, another gale's forecast. Yeah, I was saying the one off Japan was probably the last one of the season. No, another gale forecast over the dateline on Monday, the 20th of April, with 31-foot seas. Do we get any more out of it? Nope, 31 feet, sort of passing off. You see swell. Here's Hawaii. There's the leading edge of the swell, pushing into the Hawaiian Islands, maybe somewhere on late Thursday or Friday, and perhaps energy from it also pushing into California on Friday. That's something to watch, at least north of Point Conception. And then after that, just roll through this. Literally nothing else is forecast, and kind of suspect the northern hemi is done for the season by that time. The North Atlantic, put this into motion, see if there's any activity forecast. 29-foot seas, almost 30 feet here on Tuesday night, the 29th of April. Looking to target mainly Ireland and that area, probably not anywhere else getting anything meaningful. And beyond that, really nothing happening. Like I said before, same holds true for the Atlantic as the Pacific. Northern hemi going to sleep. Focus is on the southern hemi. Looking to the South Atlantic, little bit of a gale here forecast south of Africa, but again, all these falling southeast, same deal. You want them pushing off to the northeast to push meaningful swell up to you. But because it's so close, you see limited energy pushing into the southern tip of South Africa there. Pretty good system, though, as it passes Africa. Then let's see where else. We're off into Thursday and Friday, 20-foot seas, Friday night into Saturday. Maybe some swell to result, eventually targeting South Africa. And then to the Indian Ocean. Let's put this into motion, see what we got. You see the first two systems pushing under Africa. Then it starts to regenerate in the, call it the Southwest Indian Ocean, lifting well to the north. That is what you want right there to target this whole area right in here. You can literally see the swell front pushing into Western Australia as we get into Friday. And secondary energy behind that, you see the swell pushing up towards Bali and that area as we get into Sunday, the 4th of May. And that's where we are, and more energy. So a bit of a swell machine looking to start up, targeting mainly Australia, but certainly the Indonesia as well. Local wind forecast for California right here. So that'd be Southern California, Point Conception there, San Francisco there, Northern California here, Hawaiian Islands right over here. High pressure, in control, pressure gradient. That is pressure pushing close to the coast here, tightening the isobars, creating wind. 20, 25 knot northwest winds. That's what we have. It's pretty much a blown out mess from Point Conception northward. Even though there is southern hemi swell pushing up underneath it, local northwest wind swell is being generated at the same time. Trades pretty well east of the Hawaiian Islands, probably not doing anything to produce meaningful wind swell. So we get into Monday, same sort of pattern. Winds back off a little bit, 15 knots near the coast, 20 knots offshore. But you see the high pressure here, winds rotating clockwise around it. Now, here you go. Better shot at the easterly wind swell machine for the Hawaiian Islands, trying to get organized. So we get into Tuesday. Now, here's a little bit better setup where the northwest winds are isolated to Northern California, not really pushing into Central California, and certainly not Southern California. That would reduce, you get the wind swell, but at least you don't get the northwest winds and all the local chop. Trades continue for the Hawaiian Islands, generating wind swell. Wednesday, gradient holds still. I mean, this is going to drop water temperatures probably down to as far as Monterey Bay, if not a little bit more. Trades start fading for the Hawaiian Islands. As you get into Thursday, gradient finally fades. Low pressure builds in the Gulf of Alaska. Same low that was previously over the dateline, generating swell for Hawaii. Trades subside for the Hawaiian Islands, just down to about 10 or maybe 15 knots. Get into Friday. Here comes the next bout of high pressure. Look at this, filling the Gulf of Alaska. You see northwest winds already starting to build. Trades 15 knots for the Hawaiian Islands, solid generating wind swell. We'll just get right into Saturday. Here we go, a broad fetch of 20 knot northwest winds, lots of wind swell. It would trash whatever southern hemiswell's hitting at the time. And notice it almost looks like it's pushing into Southern California. Let's just notice the trades for Hawaiian Islands. We'll just keep going here, though. As you get into Sunday, a week from now, 30 knot northwest winds, 25 knots the whole way into Southern California. Just a mess, and upwelling likely to be caused, dropping water temperatures. We're actually doing kind of okay, at least for the moment. Nice broad fetch of east winds targeting the Hawaiian Islands, generating east wind swell. And there we are, 180 hours out, still a continuation of the same pattern. It looks like springtime is going to get its revenge after all. And believe it or not, rainfall for California. Here we go. Southern California down here, Central California, Northern California here. It was actually snowing this morning when I went and looked at the cams up in the Tahoe region. And it kind of has backed off down low. And I mean, if you actually look down low, there is nothing on the ground. Even though it was snowing, none of it really is sticking. But it kind of gave you a little bit of a tease, at least. A little bit of rain here along the Central California coast. Theoretically, I think you could best qualify this as just potential for showers, though you see the snow in the Sierra again. But as we get into this evening, all that clears out. Here comes high pressure, and that's the end of that. Or so we think. Oh, you see another little backdoor something on Wednesday, Thursday, maybe limited to the Sierra and maybe the southern Sierra, just a hint of snow or rain there. And then another front comes down the coast, rain on, so we're talking Friday night into Saturday for Northern California, maybe to Santa Cruz, a little bit of chance of snow there for the Sierra again. We'll see what the snow forecast looks like. This is probably all grossly overhyped given the time of year and just the way this season has been. But you get the idea. Summer not moving in just yet. The snow forecast dashboard for Palisades, Tahoe, formerly Squaw Valley. Yeah, this morning's run showed like 6 inches, or that was actually last night's run. This morning's run knocks it back down to about 3 inches. And that's up at the summit. Maybe they got 5 or 6 inches. Now, another little bit is supposed to be coming in Friday night into Saturday. Total accumulations maybe around 6 inches. Let's go look at one or two other resorts. Kirkwood forecast about the same. What's that? 2 inches, 3 inches, and then another couple after that. And then Mammoth, not really getting any from this initial system. Maybe an inch from the midweek or the late week one. And then as we get into next week, this would be like Monday or something, Sunday or Monday, theoretically 10 inches. Yeah, I don't know that I would believe that, but it looks nice. And then looking at the snow elevations, this is for Palisades, Tahoe. The base of Palisades, 6,200 feet, the black line here. Summit at the top of Granite Chief and Palisades about 9,000 feet, probably like 89.5, something like that. Reds would be liquid precipitation. And the precip is where these little yellow squigglies are, okay? Gray would be sleet. That'd be like 35 to 32 degrees. The gray-white interface is the 32 freeze line. So today, the 27th, yeah, freeze level down supposedly at 5,000 feet. But then you're up above the summit pretty quickly after that until we get into the 3rd, that'd be Saturday and Sunday, again down to about 5,000 feet, and then heading right back up directly afterwards and up to 12,000, let's call it 10 to 12,000 feet beyond that. Definitely a springtime pattern, warming, cooling, warming. But the snowpack, definitely not building any, and if anything, it's shrinking as things get steadily warmer. So what's all this mean in terms of surf? We'll start up at the Columbia River area, Portland, inland from there. Surf height's 2 feet as we get into Monday. Theoretically building to about 5 feet on Tuesday, dropping down from there back up to 5 feet on Friday, and maybe even 7 to 8 feet on Saturday into Sunday. South winds in control at times. You can see the wind speeds and directions here. Go look at actual swell sizes. Mainly wind swell 3 feet at 7 seconds. A little bit of southern hemiswell trying to peek into, I don't know where you would find a break to be able to deal with this. 1.5 feet at 15 seconds. That's today. And then mainly it's just dominant wind swell at about 4.5 feet at 10 seconds, fading to 2 feet at 8 seconds. And then a little bit of the westerly swell. This would be the dateline swell showing up as we get into Friday and Saturday. 3.5 feet at 14 seconds, 6 feet at 12 seconds. So maybe some potential there. And we head down to Northern California, called San Francisco area, Ocean Beach. Surf heights is all primarily wind swell here. 3 feet. 4 feet, 3 feet, 4 feet, and then 2.5 feet. What is this? Northwest winds at 25 to 30 knots. Oh, that's just ugly. And again, 26 knots. And none of this looks particularly inspiring, though there is a fair amount of southern hemiswell. Here you go. 1.9 feet at 16 seconds, and your wind swell dominates 5 feet at 8 seconds. 1.8 at 18 seconds. More wind swell. 2.5 feet at 16 seconds. You can just read across the chart. It's just steady southern hemi swell with bouts of the wind swell. So the way this works is the integration of the height and the period, whichever one is bigger gets to be called the primary swell, and that's what jumps out on the graph here. So it's the wind swell and the southern hemi swell just battling back and forth, but they're both present the entire time, and the wind swell probably at exposed breaks is just going to be dominating. Then you go to Southern California, you don't have to worry about that much. Point Conception blocks out most of that wind swell, and it's just all southern hemi swell. 3 feet on Sunday, building to about the 4.5 foot range on Monday into Tuesday, slowly trickling down as we go through the end of the work week, but still some sort of surf nonstop through the end of the week. Swell heights, 2 feet at 15 seconds, 2.2 feet at 16, 2.8 at 16. That swell trickles down. Next one starts building at 1.2 feet at 16 seconds or so. Top spots doing better. North shore of Oahu, the current swell slowly fading from 4 feet down to about pretty much nothing as we get midweek. But then the next swell, assuming the gale north over the north dateline region builds, surf heights into the 5 foot range. That's 5 foot Hawaiian as we get into Thursday and Friday, fading down from there, and then wrapping up for this season. Swell heights, by Monday, 2.5 feet at 11 seconds, trickling down, rebuilding up to almost 4 feet at 13 seconds on early Friday or late Thursday, depending how you split it, and then trickling down from there with trades for the most part in control. And then Bali, because we know there's some surf coming there. All right, surf heights 6 feet, fading to 5, back to 6 feet as we get into Wednesday, fading a little bit, and then coming back, just steady like head-high surf, it looks like, with winds, some degree of, well, let's see, hard to say. It was that southeast, then turning pure east as we get later in the week. Swell heights, 5 feet at 12 seconds, 4 feet at 12 seconds, 4.8 feet at 12 seconds, 5 feet, they wind swell in the mix, and then more southern hemi swell at about 3.5 feet at 14 seconds as we get into next weekend. All right, let's go take a look long term. What's going on with the two major weather oscillations that affect swell production in both the north and the southern hemi? The MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We'll start by looking at the MJO and by looking at data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino, but also give us some clues as to what's going on with the MJO, or perhaps lack of MJO, or perhaps lack of ENSO. As the title said, ENSO neutral, finally. No more La Nina. I mean, we've been in a stretch of some flavor of La Nina other than 1 year of El Nino for 5-6 years or more. Neutral would be a significant change. Maybe not a great change, but better than being in La Nina. Anyway, so we're looking at data from these buoys. There are wind sensors on the buoys. We're looking at wind directions here. Why does that matter? Well, there are two phases to the MJO, the active phase and the inactive phase. The active phase is like a low pressure system, the inactive phase like a high pressure system. The MJO, both phases, on opposite sides of the planet, rotating west-east around the planet on the equator. The active phase is our friend because it's a low-pressure system. It takes warm, moist air at the ocean's surface, lifts it aloft. That energy feeds the jet stream. A stronger jet stream is more efficient at carving out troughs and therefore building gales and therefore creating surf. Inactive phase of the MJO is a high-pressure system. It creates downward falling air. That downward falling air cuts off energy to the jet stream. The jet stream gets weak. It splits. It does not form troughs. Instead supports high pressure down at the ocean surface. So, with the active phase of the MJO, because it's a low pressure system and trades are generated by high pressure, if there's low pressure, and this is, we're talking just on the equator, if the active phase of the MJO is over a portion of the planet, it dampens trade winds, okay, because it's a low pressure system, and if it's strong enough, can actually reverse trade winds. Right, so we're looking at actual wind speeds here over the East Pacific. This is the equator right here. East Pacific here, West Pacific here, New Guinea there, date line right there. Trades blowing out of the east, not looking particularly strong. Over the Central Pacific, same deal. West Pacific, same deal. But it is not the actual wind speeds that matter as much as the anomalies. Difference from normal for this time of year. And looking in the East Pacific, we see pretty much completely normal. In the Central Pacific, we're just looking for the wind arrow directions, and if you can't really see anything, that means you're as neutral can get. Same thing pretty much over here in the West Pacific. So, kind of looks like ENSO neutral, or at least MJO neutral. Maybe. Let's go look and see what some other data says. 850 millibar zonal wind anomalies for the entire planet. But all we're concerned with here is the Pacific. So the far West Pacific starts at 125 east, so right about there. And the far East Pacific ends at about 80 west, so right here. You almost see a seam in the line here, okay? Blues are easterly anomalies. Yellows, reds, westerly anomalies. The blues, these would be enhanced trades. That is the inactive phase of the MJO. The yellows and oranges, the active phase of the MJO. Weaker than normal trades, if not westerly anomalies. So this is what has been going on for the past, since late March. So all of March, so past month, let's say. Right? Yep, past month. You see persistent westerly anomalies here over the maritime continent with persistent easterly anomalies over the dateline region. And that tells you that either the MJO is stalled or that La Nina is in control, which it is right here over the dateline, easterly anomalies. And then here we are today. Westerly anomalies have built in the past 2 weeks to almost halfway over what we call the Kelvin wave generation area. And this is really what matters. It's not the whole Pacific, it's the West Pacific that's mattered, because if you have westerly anomalies there, that's what starts feeding the jet stream. The jet stream starts moving downstream from west to east over the rest of the Pacific, and then that's where it generates its storms. So right now, there's a good pile of fuel, if you consider that, right here in the West Pacific, and the forecast has it continuing to hold, entering the Pacific, and notice this, almost filling the entire equatorial West and Central Pacific at the, let's see, that would be 2 weeks from now. Okay, that's actually not very long. And over the next week, I mean, we are actually, considering where we were April 17th, we are in a much better place than we were then. Enough that I think I could say that La Nina is dead, even though there are residual easterly anomalies here forecast for about the next week. After that, it's over, and there's a whole bunch of other data that we need to go through that sort of helps drive this theme home. So let's keep digging. Outgoing long wave radiation, just another fancy word for cloud cover. If you have the active phase of the MJO and it's a low pressure system and it's taking warm moist air, lifting it aloft, that warm moist air eventually is going to condense. Okay, and it will manifest itself on any cloud cover anomaly chart as more clouds than normal. That's what the blue is, more clouds than normal. Now, this is a statistic model. Let's get ourselves oriented. South America, Central America, Hawaii, New Guinea, there, the equator right there. The date line, 180 west right there. And we have 1, 2, 3, 4 panels, 5 days each panel. So active phase in the West Pacific on day 0, fading on day 5, inactive phase, these yellows, clear skies, no clouds, more sunlight bouncing off the ocean surface, and continuing 10 and 15 days from now, according to the statistic model. But the GFS model, the dynamic model, the same one that we were looking at in the previous chart, shows active phase on day 5, day 10, building on day 15. This model has consistently been saying this sort of an outcome, while the statistic model has continuing to show this sort of an outcome. So there is a bit of difference between the two. Let's go look at the phase diagrams from each. These are the drill downs for the statistic model and the dynamic model. They just show you where the active phase is and how strong it is. How do you read the chart? Well, the MJO moves from west to east, from the Indian Ocean, kind of organized or gets built in the Indian Ocean, moves to the maritime continent, then to the West Pacific, East Pacific, under the United States, across the Atlantic, back to Africa, and its last little remnants wander back into the Indian Ocean and reorganize. The heavy dot is where the active phase is today, so in the West Pacific. The further the dot is outside of this circle, the stronger the active phase is. So a very weak active phase, and there's 1, 2, 3 different charts here. This is the statistic models suggesting it moving to the Indian Ocean 2 weeks from now. The dynamic model, though, has it meandering around and somewhere still in the West Pacific 2 weeks from now. So again, the two models, yeah, they both agree on where it is, but the outcome or where it's going to be 2 weeks from now, vastly different. Now here is another, this is the real, just mind bender. This is, again, upper level, support for upper level precipitation or moisture. Greens, wetter than normal air. One would assume the active phase of the MJO. Oranges and reds, dry air, the inactive phase. South America there, New Guinea there. 0 is the equator. Dateline running right down the middle. This is a statistic model, all right? And it's interesting because now this is what been about a month now. Active phase just keeps showing stuck right here, not moving into the West Pacific as it's depicted here. See it's depicted moving across the Pacific and then into the East Pacific about the end of May, and with the inactive phase building. But instead, the MJO is kind of stuck where it is in the West Pacific. I think some of that is this slowly fading La Nina pattern that's sitting right on the date line. Until it gets completely dislodged, the MJO is just going to stay where it is. Maybe. We'll see. Let's keep digging. 850 millibar zonal wind anomalies, same sort of chart as we saw earlier. This is from the CFS model, and it goes out a month. All right. So here, and this MJO is the black solid contour. So you see, date line runs right up the middle here. West Pacific starts at 125 east, so right here. So you see the preponderance of easterly anomalies, active phase, inactive phase, it doesn't matter. Easterly anomalies in control. You actually see the low or the high pressure bias outlined right here in this contour. And as it's been shrinking, the intensity and the width of the easterly anomalies keeps getting smaller and smaller. Now this just showed up, a weak active contour showing up over the West Pacific with westerly anomalies halfway across the Kelvin wave generation area. It goes from 125 east to about 170 west, starting to fill, building to about May 12th, something like that. Easterly anomalies holding, but then completely collapsing, and neutral to westerly anomalies forecast taking over the Kelvin wave generation area. So that model, that version of the model we just looked at, seems to be really strict and almost conservatively biased in the way it is presented, which is good. Nothing wrong with that. This is a little bit more liberal view, if you will. Past performance down here, the forecast up here. Dateline runs right up the middle. Okay, West Pacific starts at 125 east. Westerly anomalies again. Okay, this is the past performance. Solid easterly anomalies. As of this, last little bit of easterly anomalies holding for about maybe 4 or 5 days, with westerly anomalies already filling half the Kelvin wave generation area. And by Friday, something like that, westerly anomalies taking over the whole Kelvin wave generation area, almost to a point south of California. And then you see them building as we go 3 months out. Let's overlay the MJO. Current weak active phase of the MJO in control theoretically should just knock the socks off the last little bit of La Nina. with westerly anomalies building over, and pretty much all the models are saying that. It's just a question, was it 5 days from now or is it a week or two from now? Hard to tell. Then we get into the inactive phase as we get into the first part of May, but westerly anomalies persist. And then when you get into June 22nd, well, actually starting about June 16th, something like that, strong westerly anomalies start building with a strong active phase of the MJO in control. Now, that's a model going 3 months out, right? I don't believe a model even a week out, but this model does a pretty good idea of maybe not the specific date and time, but the general trend moving forward. And why would this trend be? Well, let's overlay the low-pass filter. All right. The dotted contour, high pressure bias. This is your El Nino, La Nina indicator. High pressure over the dateline, La Nina. The third contour, supposed to be gone. Exactly at the same time these easterly anomalies disappear in about 4 days. The second contour fades out by May 21st. The third contour is east of the Kelvin wave generation area by about June 6th. As the low pressure bias, which has been locked solid over the maritime continent all winter, then somewhere starting around here, May 21st, starts slowly inching further into the Pacific, and by July sometime, filling the dateline region. That would be interesting if it happens. I think this is way overhyped. I'd be happy to get 5 days from now and see this sort of pattern right here. Westerly anomalies on the dateline is great for feeding the jet stream. It's great for supporting, it's sort of like a weak ongoing active MJO in the West Pacific, therefore feeding moisture up into the atmosphere, feeding the jet stream both north and south, and that would be sort of the beginnings of a ENSO neutral pattern. So what does the ocean say is going on? Let's go take a look at subsurface water temperatures, and there's some really interesting stuff going on here as well. So this is data from the TAA buoy array, again, that series of buoys strung across the equator. These are the anchor lines on the sensors. The X's are actual these are the anchor lines. The X's are sensors on the anchor lines. Okay. This little block here dropped off just like 2 or 3 days ago, and I'm wondering if NOAA isn't out there actually actively trying to upgrade the buoys in this area. That'd be really great if they were. They did this earlier over in this region, so if the sooner they can do this, the better. So we'll see. It'll probably be a couple of weeks till this data returns. Anyway, 29-degree isotherm. Oh, anyway, yeah, we're looking at where the balance of warm and cool water is. Looks like warm water all balled up in the West Pacific, the cooler water more in the East Pacific, typical of La Nina. If trades are blowing harder from east to west, then they would scrape all the warm water here and push it off to the west. 29-degree isotherm, right where it was last week, and at 160 east. But the 28-degree isotherm, which is, I think it was at 173 or something last week, has now moved to 164 west. So warm water pushing off to the east. The only way that would be happening is if you had a slackening of trades in this area. And the 24-degree isotherm, well, we can't see what's going on here, but all in all, warm water seems to be moving off to the west or to the east. And then we look at the anomalies, the difference from normal for this time of year, and what this area all up here was filled with cooler than normal water temperatures up to last week. And then there was a thin little finger of warm water or neutral water across here. Now it's gotten bigger. The last little bits of cool water, according to this, are just in a couple little pockets. Yes, there is a subsurface pocket of cooler waters here. I don't know that really is going to make any difference, though. The buildup of warm water here is definitely a precursor of the crashing of trades, or at least the neutralization of trades in the Equatorial Pacific. Now, this image uses the same data, but also uses some satellite data to paint a higher res, but it's about a 5-day behind kind of view. And this is what is really amazing here is, well, one, the temperatures here slowly getting warmer and warmer. Yeah, 1-2 little pockets of cooler waters, but we're talking half a degree below normal. But the real big thing here is this wasn't here last week where you had there was this here, but the warm temperatures did not reach east of 160, and all of a sudden you see what looks like a Kelvin wave or a river of warm water starting to work its way across the Pacific. If this is real, this is a significant development. I'm going to give the satellite data. It does a complete pass about every 5 days, so I'd give it 5 to 10 days to know if this is really like a Kelvin wave or just a series of blotches of warm water, but very, very much looks like a Kelvin wave pushing off to the east. Here's the satellite data used to build that image. Sea level anomalies. Is the height, the sphere of the ocean higher or lower than normal? Why does that matter? If you have cold water at depth, cold water, oops, there we go, contracts. When it contracts, it'll create a divot on the ocean surface. Warm water at depth expands. When it expands, it'll displace water above it up. All right, so if you use a satellite, map the whole ocean surface, takes about 5 days. And then you're looking to see, is the surface height just from 5 degrees north to 5 degrees south on the equator? And there's the equator, date line there. Chile, Peru, Ecuador, Central America, New Guinea there. What are the anomalies in this little zone along the equator? And the notable change this week is it's basically dead neutral on the equator once you get past the Galapagos the whole way out. And if anything, higher than normal. So this, of course, means warmer than normal water over here in the West Pacific. We knew that, but we've had persistent negative anomalies in this region. Very typical of La Nina, given cold water at depth, or inferring cold water at depth, and stronger trades than normal in this area. And all of a sudden, that is crashing. Yes, we have these 2 pockets here of cooler anomalies here, but my guess is if the equator, whatever happens on the equator, follows as you get further north and south from the equator. So at this point, it looks like we're neutral. Upper ocean heat anomalies for the past year. West Pacific here, red's showing warmer than normal temperatures. East Pacific here, this would be like Ecuador, and the blues, colder than normal temperatures. You can actually see Kelvin waves from weak active phases of the MJO trying to push through this cool pool, but not being successful until April. Now, is this a real Kelvin wave, or is it just easterly anomalies fading and temperatures returning to neutral? I think that's probably where I'm going with this. I don't really want to say Kelvin wave because that's just too much to kind of hope for, even though these are officially qualified as downwelling Kelvin waves, warm water Kelvin waves by NOAA. And this for sure then certainly would be, but, you know, is it a Kelvin wave in the sense that it's a buildup to El Nino? No. It's just sort of we're returning to a neutral pattern. Notice you have warmer temperatures here off of Ecuador too. So this is rapidly evolving towards neutral. That is the main point. Subsurface, rapidly evolving towards neutral, if not there already. Surface winds, rapidly evolving towards neutral with westerly anomalies forecast to take over in 5 days and easterly anomalies becoming shunted further and further off to the east, all suggesting the demise of La Nina. Sea surface temperature anomalies, South America, Central America, equator right there, date line 180 west right there, and New Guinea over here. 5 degrees north and south of the equator is all that matters. We have generally warmer than normal temperatures in the East Pacific. Yeah, you got your standard kind of upwelling thing that always goes on along Peru and Chile this time of year. High pressure out here generating south winds, exactly like the high pressure building in the Gulf that makes the the northwest winds, their trades effectively for California, and that then wrap around south of Hawaii. Okay, we have a couple little pockets of cooler water, but we also have an equal number of pockets of warming water, suggesting, and the Nino 3.4 region. This is the official El Nino monitoring region. 120 west, 5 degrees north and south of the equator, out to 170 west. So this box right here. Warmer in the south, cooler in the north. Normally it's the reverse, it seems like. So, but it looks like we're moving quickly towards a neutral pattern, if we're not there already. The trend for the past 7 days, even better. South America, Peru, Ecuador right here. This region right here last week was blue. The week before that was dark blue. This suggests now that temperatures are warming. That can only be attributable to trades dropping here. It was the inactive phase of the MJO moving over this area. So I think it is maybe moving more than what some of the products suggest it is. And then we have generally warming temperatures out here over the date line to a point, to 140 west. So just right in here, that's the last little bit of anything that even remotely resembles cooling. So it appears a neutral pattern is trying to set up. Sea surface temperature anomalies in the Nino 1.2 region. This is the area right there by Ecuador and the Galapagos. Temperatures, well, they were dropping recently because of the inactive phase, the MJO there. Today's values, 75 thousandths of a degree below normal, basically dead neutral. And they were above normal for February, March, April, for 2 months prior. So would seem reasonable that maybe these temperatures are going to start building back up. But in the official El Nino monitoring region, the Nino 3.4 region, temperatures today 167 thousandths of a degree below normal right there, dead neutral, 0. So again, you go, well, it's negative. Yeah, but pretty much anything from positive 0.5 to minus 0.5 is considered neutral. There's always variability in the atmosphere. Nothing is ever just like locked solid at dead neutral. But the trend definitely slowly creeping warmer and warmer and officially categorized as neutral. Here's sea surface temperature anomalies corrected for the Nino 3.4 region right here. Minus 0.2 degrees the week of April 16th. Looking forward to seeing what the next update will be. Maybe it comes out as early as tomorrow. But you see, even since February 12th, we've been officially in neutral territory, sea surface temperature-wise. What does the atmosphere think is going on? We look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Tahiti in the Pacific, Darwin in the Indian Ocean. When pressure is lower over Tahiti, the index goes negative. Hey, we are negative, minus 11.47. And we've been pinging around between neutral and negative for about the past 12, 15 days, something like that. So you can see we were definitely much more positive in the later part of March, early April. But now we've been heading steadily downwards. Suspect that is due to the active phase of the MJO, westerly anomalies like we saw on all the previous charts, moving over the West Pacific. 30-day average, plus 5.47. So that is officially neither inactive or active phase. That would be ENSO neutral. But this moves around a lot in response to the MJO, and what you need is a steady, active, or more instances of the active phase of the MJO, longer lasting than the inactive phase. So I'll take this with a grain of salt for right now. The 90-day average, again, it's looking back 90 days, plus 7.28. Where were we a month ago? 5.47. So no real change there, but by the time it changes here, I think we'll all well know where we're headed. And here's the graph, okay? Plus 7 is considered neutral right there. There you go, the 30-day average, officially in neutral territory. The 90-day average at 7.28 up there. That's just almost approaching neutral. Either way, all indications we're heading towards, if not already there, at ENSO neutral. And yet one more indicator, outgoing long wave radiation anomalies. Again, oranges and reds here would be drier than normal skies. That would be the inactive phase of the MJO. Blues, wetter than normal skies. Now the date line is at 180 west, so right there. And you can see since October, drier than normal skies over the date line. Classic La Nina kind of setup. But as of today, it looks like it's pretty much gone or nearly gone. We don't have wetter than normal skies moving into the Pacific just yet. But I think the collapse of easterly anomalies will pretty much allow westerly anomalies, rising water temperatures, evaporation, that pattern to set up, and then you start building the more cloud cover over the dateline sort of pattern. It'll be probably 2 or 3 months, though, till that happens. Sea surface temperature forecast for the official Nino 3.4 region from the CFS version 2 model. Well, we've been basically ENSO neutral since, so about February, March, April, and the forecast the whole way into January is, 1/10 of a degree one way either side of neutral into this coming winter. And we're, 9 months out from that or something, 8 months out. So pretty much screaming ENSO neutral. And the consensus model, all the ENSO models, it updates once a month. It did it here last week after we posted the video. Statistic model average, you see it hovering right at 0. The dynamic average right there hovering right at 0. This goes out till December, January, February. So this is 3-month periods, average temperatures over a 3-month period, hovering at neutral. But let's go dive in. For the dynamic models here, here's all the different dynamic models, and it does it April, May, June, July, on down. Average of the dynamic models, month by month, hovering within a 1/10 or less of dead neutral the whole way into December. Statistic models, here's the average of the statistic model. Basically the same thing, maybe biased just a little bit cooler at minus 150 thousandths of a degree. And then here's the average of all the models, throw it together. As neutral as one can possibly get. So right now, all eyes on the southern hemi. 7 storms have passed across the South Pacific and/or are forecast over the next week, producing swell after swell of southern hemi energy. Now, unfortunately, almost none of it's getting to Hawaii. And what gets into California is pretty much sideband energy. Regardless, it's rideable surf, and if you don't like that, there's plenty of wind swell north of Point Conception, so you can make use of that. One more little gale in the North Pacific will provide, theoretically, surf for North Shore of Oahu as we get later in the work week. And then after that, I think the North Pacific is done for the season. Stick a fork in it. And the southern hemi becomes our main swell source. Things looking good there. Looking longer term, the La Nina pattern, the Modoki La Nina, sort of La Nina that we've been having, looks like it is all but done. We're just waiting really to officially declare it. I'd say I'd like to see westerly anomalies building over the dateline region, but we are within 4 or 5 days of that happening. So I think, and with all the other data, especially what appears to be a Kelvin wave pushing across the Pacific, the first real one in a year or two, and then the demise of positive outgoing long wave radiation over the dateline. Like to see the development of clouds over there, but that's going to be another month or 2 or 3 incoming. But it looks like we are approaching ENSO neutral. It will take 3 months for that to really build into the atmosphere. So We're in April, so May, June, somewhere in July, I'd really expect to start seeing the effects of ENSO neutral on whatever's going to happen. That said, Southern Hemi, Jetstream, swell production machine, really quite active given the time of year. It's not looking pretty good. I'm hoping that as we get deeper into neutral, because the atmosphere is swinging from La Nina, even though it's weak, to neutral, that is momentum in the atmosphere. And if it keeps swinging just a little bit more, I think that bodes pretty well from what we're going to be doing as we get into fall and winter next year. Right now, though, the focus is on the Southern Hemi. Make the most of what you can get and keep your fingers crossed for more. All right, that's our video for this week. If you enjoyed it, give us a thumbs up. If you haven't subscribed, please subscribe. Stormsurf icon down in the lower right-hand corner of your screen. Click it, get all signed up. If you have comments or questions, write them up down below. We'd be happy to answer. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. Thank you so much for your donations, and we will do this again next week, same time, same channel. Thanks so much for watching.